Today, we're going back, I mean way back. Not just to the beginning of the universe, but to the impossibly small moment that might have come even before the beginning. We're going to dive into one of the biggest, most powerful ideas in all of cosmology: cosmic inflation.
You know, we talk about our universe being 13.8 billion years old, and that number is so huge it's kind of hard to wrap your head around. But the real secret, the event that basically set the stage for everything that followed, happened in a slice of time so small it almost doesn't make sense. So what on earth happened in that first, fleeting moment?
To answer that, we gotta adjust our thinking a bit. We all have that picture of the Big Bang, right? A single, tiny point just exploding outwards. But the theory of inflation, well, it suggests there's a preface to that story, a kind of opening chapter that had to happen for our hot, dense universe to even exist in the first place.
So let's look at the schedule for the day, cosmically speaking. Right at the very start, you have the Planck era. This is a period before 10 to the minus 43 seconds, where our physics, it just breaks down. We have no idea. But right after that comes the main event for us, the inflation era. Then that's followed by a super important phase called reheating. This is where all the energy from inflation got converted into the stuff, the matter and light, of that primordial soup, which then kickstarted the event we all know as the Big Bang.
Okay, so we've placed it in time. Now let's get to the good part, this absolutely unbelievable, universe-defining stretch. What exactly was it?
So here's the key idea. Cosmic inflation wasn't just things moving apart. It was accelerated, exponential expansion. Imagine something doubling in size, then doubling again, and again, and again, all in a split second. The theory goes that this was powered by some kind of hypothetical energy field. You can almost think of it as a form of cosmic anti-gravity that forced space-time itself to expand at a rate that is just, well, it's mind-boggling.
And how long did this whole era last? Well, it might have all gone down around 10 to the minus 37 seconds, after whatever came before. That's a decimal point followed by 36 zeros and then a 1. I mean, the blink of an eye is an eternity compared to this. It's almost no time at all.
But here's the absolutely wild part. In that tiny, tiny sliver of time, the universe expanded by a factor of at least 10 to the 27th. That is a 1 with 27 zeros after it. To try and put that into perspective, something the size of a single proton would have stretched to be bigger than our entire observable galaxy is today. It's just incredible.
But look, this amazing idea isn't just a cool story cosmologists made up for fun. They came up with it because it perfectly solves some of the biggest head-scratchers that the old Big Bang model just couldn't explain. It was truly the missing piece of the puzzle.
And two problems in particular were real doozies: the horizon problem and the flatness problem. Seriously, without inflation, these are deep paradoxes about the universe we see around us. But once you add inflation to the mix, they suddenly make perfect sense.
Okay, so let's tackle the horizon problem first. It basically asks, why is the universe so uniform? The temperature of the cosmos is incredibly even everywhere we look, even in spots that are so far apart they shouldn't have ever been able to exchange heat. Inflation's solution? It's genius. It says that before that great stretch, all those regions were touching. Our entire observable universe grew out of a single connected patch smaller than a proton. Then you've got the flatness problem, which asks why the geometry of space is so perfectly flat on large scales. Inflation's answer is just as slick. It stretched space-time so ridiculously much that any curve it started with got smoothed out. It's like blowing up a tiny, wrinkled balloon to the size of the Earth. For an ant living on its surface, it would look perfectly flat.
So, inflation solved these big, old problems. But it did something even more amazing. It didn't just iron out the universe's geometry. It actually planted the seeds for everything in it.
This idea is just so cool. See, down at the subatomic level, the universe is this buzzing, fizzing sea of tiny, random quantum fluctuations, little bits of energy and matter just popping in and out of existence. Normally, they're microscopic, but during inflation, these tiny jitters got caught in that massive expansion and were stretched to astronomical sizes. And those slightly denser spots became the gravitational seeds around which all the galaxies and all the cosmic structures we see today would eventually form.
But here's the twist in the tale. While inflation explains so much about the universe after it happened, it also acts like a giant cosmic curtain. The sheer violence of that expansion basically erased any and all information about whatever came before it. It completely wiped the slate clean, which means our verifiable history of the cosmos might be forever stuck starting at the moment inflation ended.
Now you might be thinking, hold on a second. Isn't the universe expanding right now? And isn't it accelerating because of something called dark energy?
It's a great question and a common point of confusion. But the truth is, they're two very, very different things.
Let's break it down. Cosmic inflation was like a cosmic sprint, an unbelievably fast, incredibly powerful burst right at the very beginning. Dark energy, on the other hand, is more like a cosmic marathon, a much, much gentler acceleration that only really kicked in a few billion years ago. They were driven by different forces at different speeds in totally different eras of the universe.
So let's just quickly recap the big ideas here. First, inflation was this period of insane hyper-expansion at the dawn of time. Second, it neatly solved those huge cosmic puzzles, the horizon and flatness problems. Third, it took tiny quantum jitters and blew them up to become the seeds for every galaxy out there. And finally, remember that it is a totally separate thing from the dark energy that's causing the universe to expand today.
And that leaves us with one last, kind of profound thought. Inflation is the key that unlocks why our universe looks the way it does. But it's also a veil drawn over creation itself. It answers so many questions, but it leaves us staring at the biggest one of all. If inflation wiped the cosmic hard drive clean, what secrets about the ultimate beginning of everything might we be destined to never ever uncover?